Right, okay, and we are go. Good. Hello, everybody. Welcome to week 2. And this is your lockdown bioinformatics. So hopefully you all caught up with week 1 and ready to get going with week 2. What we're going to do this week is we're going to start to work with some data. So last week I showed you how to get going with the Linux generally and how to work with the file system a little bit. And this week we're going to start to actually get our hands on some data and try and do some interesting things with that data starting today. So the first thing that we're going to do after we've started up our VMs is we're going to download some data. So to do that, we're going to use wget, which we looked at last week, wget. So wget allows us to download data that's available over a normal kind of internet link, so either HTTP or FTP. So I've prepared some data this afternoon that we're going to download from one of my servers at Newcastle, and that will give us something to work with over the next couple of days as we explore some tools that we can use at the Linux command line for working with data. So later on, as we kind of progress, we'll be looking at tools other than the command line for working with data. So at some point we will start to look at using the R statistical environment and using that programming language to investigate data. But right now we're going to use the tools that we've got to hand, which is our command line tools for exploring an example data set. The first thing that we need to do, as with any of these lessons, is start our VMs up. So if you haven't already, go to VirtualBox and start your Ubuntu virtual machine. So I'm going to hit start on mine and my machine's going to boot up, which hopefully shouldn't take too long. And here we go. So my machine's starting. There's my boot screen. And in just a second, we should have a running VM, which seems to have taken itself off the screen for some reason. Up we go. Okay. So there we are. My VM's up and running, and we need our command line. So we need our terminal. So click on the little mouse and click on terminal emulator, and that gets us our terminal. So I'm going to maximize that, and this is what we're going to use. So the first thing I'm going to do is a little bit of housekeeping. So last week, when showing you around, so I'm going to go to my share directory using cd. So that'll take me into my share directory, pwt, confirm that I'm in there. So last week when I was showing you around and showing you the tools that I was demonstrating last week, I ended up creating quite a lot of files in here. A little bit of cruft has accumulated from me demonstrating various things. So the first thing that I'm going to do this afternoon is I'm going to tidy that up a bit. So what I'm going to do is I'm going to create a subdirectory, and I'm going to move all of last week's files out of the way into that subdirectory so that we can start afresh with files for this week. So first things first, we're going to make a directory, mkdir, to keep last week's files in. So I'm going to call it week 1. Okay, so that will make me a directory called week 1. And we can confirm that that's done what we expect it to do by typing ls. And there we go. At the end of that listing of files, we've got our new directory called week 1. And then what I'm going to do is I'm going to move everything that we created last week, all of these files that we created or downloaded last week, I'm going to move into that week 1 directory. So to do that, I'm going to use mv, which is the command to move files. And I'm going to use some wildcards. So almost all, but not quite all, but almost all of these files have the word file in them. Okay, so that was just because I was doing a whole load of demonstrating. So if we mv star file, that will move everything with the word file at the end of the name, and we want to move all of those things into our week 1 directory. Okay, so that will move. This command will move all of the files which end with the word file into our week 1 directory. Okay, so we'll run that. And remember, none of these commands give us any feedback. They don't tell us if they've succeeded or not. They just return us back to our command prompt. So if we type ls, then we can see that those files, all of those files that end with the word file, they're all gone from our present working directory. And if we ls week 1, you will see that they have appeared in there. So we've successfully moved those files from our present working directory into our week 1 directory. But we've still got a couple of files left to move. So again, if we ls our current working directory, you see that we've got our 2 files that we downloaded from Uniprot. We still have those in this directory, so we want to move those into our week 1 directory as well to get those out of the way. So to do that, I'm going to type mv, and then I'm going to hit the Q character, which is the beginning of both of those file names, and then I'm going to press the tab key, which is the key above the caps lock, if you remember. And if I press tab, it auto-completes the beginning of those 2 file names for me, because both of those 2 file names start with the same Uniprot identifier because they're downloaded from the same Uniprot entry. So that's quite a helpful thing to be able to do. I've got the .fasta and the .text files for this Uniprot entry, so that's a sequence in the FASTA format of the protein and the full Uniprot entry in text format. I can move both of those by, again, using the wildcard, by using the star wildcard, which is going to autocomplete to both of those file names. So anything that begins with Q9BYF1 dot is going to fulfilled this wildcard, which is both of those remaining files, and I'm going to move both of those files into the week 1 directory. Okay, I hit enter, and again, let's just check. So list the present working directory, those 2 files have gone. List the week 1 directory, and we find those 2 files in that directory. So that's our tidying up done. And just to keep on in this vein, what I'm going to do is make a second directory in here, which I will call week 2, which I will then use for all of the files that we use and make this week. So I'm going to mkdir week 2. Okay, so that will make that second directory. So again, ls to check that what's happened is what we expect. So we've got now 2 directories, week 1 and week 2. So I'm going to cd into week 2, which is where I'm going to do all of the examples and all of the demonstration that I'm going to do today. So what we're going to start with is downloading some data. So usually if we want a data set that we're going to work with, we almost always have to download that data from somewhere. So later on, when we come to looking at an RNA-Seq data set, we will have to download the sequencing data from either the Sequence Read Archive or the European Nucleotide Archive, depending on our preference. But we're still going to have to download that data. We can't just magic it out of thin air. And it's the same for almost any data set. We need the ability to be able to download that data. So I've just spent half an hour this afternoon preparing a data set for us to download, which is just a table of some, in this case, it is actually the results of some gene expression analysis. So it's the kind of results that we'll be looking at in a couple of weeks when we get that far with our own work. But this is some work that I've done previously, and it's just the kind of output that you get from one of the R packages that you use to do this analysis. So it's a table of results. And so I've prepared that, I've put some annotation in it so that we can read what the gene names are, and I've put that up on one of our servers so that we can all download it. So in order to download this data, we need the wget command. So that's our command, and then the argument for wget is the web location of the data that you want to download. So in this case, as I said before, I've put this on one of my servers, so http://bsu, bioinformatics support unit -serve, so that's one of our servers. dot newcastle.ac.uk, okay, because that machine is on my university web domain, so newcastle.ac.uk. On there we've got a share folder, and in that folder we have a file which I've prepared for today called example.csv. Okay, so that is the data that we want to download, and I'll just leave that there for a second just to let everybody kind of catch up with me. So the data is I've put onto our server called BSU Serve at Newcastle. It's in a share folder, and it's called example.csv. I can open this this URL in a browser, and you will see this data. It might download it or it might show it depending on the browser settings. But if we go to a browser, there's Jacob's picture of the day, by the way. We might come back to that later, but he's been, in his homeschooling, he's been looking at the anatomy of flowers. So he's done a dissection of a daffodil. This is not a daffodil, clearly, because of the red petals, but he decided to draw me a flower today, so I think that's quite pretty. So that's Jacob's picture for today. Right. Open a new tab. There we go. And then if we go to bsu-srv.ncl.ac.uk/share/example.csv, okay, it's going to want to download it on my machine. Your machine, it might just display it in the browser, but mine has downloaded it. So it's just CSV, or comma separated values file, so that opens for me on my machine in numbers. So there we go. There is a slice of that data, just so you can see it there. No, not there, not that one, this one. There you go. So you can see that data there with the columns that it's got. And that's the data we're going to download. Okay, so you've got ensemble gene IDs and some other columns of data. So that's what we're going to download. So let me close that. Go back to Jacob's picture and go back to my virtual machine. I should say at this point, if you've got any other files in your share directory that maybe you've created files with different names to me or whatever, then you should be able to move those files as well. If you just you can do them one at a time just by name. So do move MV file name week 1, and it will move it into the week 1 directory. So if you just get those files filed away into a directory for last week. So this is for this week. So wget BSU serve newcastle.ac.uk/share/example.csv, and that will download that CSV file that I've just shown you briefly in numbers. So there you go. It's gone to my server and has downloaded that file. It took a few seconds because it's not small. It's about 2.9 megabytes. And I've got that data now. So if I ls in my present working directory now, you'll see that I've got that example.csv file. So that has downloaded from the server. And if we use head, which is a tool that I showed you last week, which by default shows you the first 10 lines of a file, we can just have a peek at the top of the file just to see what it looks like. There you go. So this is a comma separated value file. You have it's effectively a table, a big square table, which has columns separated by commas on each row, and the data then is row by row as we go down. So we've got the data for ENSG 00003, and then the data for ENSG 0000419, and so on. So it's fairly standard tabular data, which we will get quite used to handling in lots of ways, both at the command line and in R later on. So now that we've got that data, we can start to think about commands that we can use to work with that data. So we've already looked at head to show us a sneaky peek at the top of the file, which is quite useful, can be quite handy. And then there are other things as well. And I'm going to introduce you to at least 4 different commands today that will allow us to begin to work with this kind of tabular data. So to begin with, it can be quite useful to know. So this is a table. We have 1 row per gene in this case. So it can be quite useful to know how big the data is that we're working with. So we know from the download, and we can look again on ls-l-h, we can look at how big the file is. So we know from the download, and you can see at the top of my terminal here, that it was about 2.9 meg. So ls-l-h tells us something fairly similar. So it's about 2.9 meg. So here it's telling us it's 3 meg. If we do it without the h, it will tell us exactly how many bytes. So just over 3 megabytes, because it's just over 3 million bytes. So it's a relatively large file, especially compared to what we've been looking at so far. We can also find out via another command how many lines there is in the file. So we have 1 entry per line. So every line in this file is a gene, apart from the top line, which is like a header line. So we can use the command wc, which stands for word count, to tell us how many lines, how many characters, and various other things there are in this file. So wc takes an argument which is the name of a file that you want to know the word count of. So wc example.csv, and that will show us 3 things about this file. So the last one is the character count. The middle one is the line count. And now I can't remember. I'm going to read the man file. So the man page to tell me exactly what wc does, because this is the thing. So when you use so many tools at the command line, is you can never remember always exactly what every single one of them does. So it can be quite useful to remember that you can look up in the man page exactly what the results mean. So you can see we've got 3 numbers. We've got example.csv as the file name, and before that we've got 3 numbers. The last number is the number of characters in the file, and that is equivalent to the number of bytes in the file. So you've got the size in bytes from ls here, and that's the same as the number of characters from wc here. wc gives us the number of lines as well. That's what -l gives us. It's the it's the line. So the 3 numbers. The first one is the line count. So that's the number of lines in the file. The second one is the word count, and that's the same as the line count here, because a word is anything that's where you've got white space between the left-hand side and the right-hand side, and there's no white space on any of my lines because they're comma separated, and the comma doesn't count the comma doesn't count as white space. So there's no breaks in any of my lines because they're comma separated values. So each line is effectively a word on its own. So that's why my word count is the same as my line count. And then the third one is the character count. So that's all of the bytes in the file. So wc here is giving me useful information about the contents of my file. And if you just want to know the line count, so if you just want to know how many entries there are in your file, then you can give wc the -l option, and that will just return you the line count for the file that you're interested in. So wc-l tells you how many lines there are in the file, and that can be useful when you want to know if you've applied some sort of threshold to your results and you want to know how many results meet your threshold. Well, then wc-l will tell you that. We can also ask how many lines are there in last week's UniProt entry. So let's ask that question. So the UniProt entry is in the directory above, then into the week 1 directory, and then in there we have the q9byf1.txt file. That's our UniProt entry, and that will tell us how many lines there are in our UniProt entry. So 898 lines in that entry. So although that may not be massively useful information, it's just using the tool for another purpose, just allowing us to see a little bit more of what's going on. Okay, so that's WC, and WC is just a little, almost a diagnostic tool, but can be quite useful. What you will have seen when we looked at our CSV file, so we looked at it in head just a bit further up here, you can see that this isn't a particularly brilliant way of laying out data. So CSV files, so if we run head again, so I'm going to use the up arrow to go back through my command history back to head, and so that's the first 10 lines of the file. CSV is great for storing data on a disk and for using that data in a programmatic way, but it's not very good for reading data. It's not a very good format for looking at data because it's not very human readable. Our columns end up having variable widths depending on the data that's in them, and it can be quite tricky. Once you're off this first screen and you've lost the header, it can be quite tricky remembering which column is which piece of data and identifying which column is which in your file. So it can be nice to have a means to get yourself a nice view of the data. And what I showed you before in Numbers on the Mac is quite a nice way of viewing the data. It's effectively a spreadsheet, and you can, all the columns are lined up and you can see everything properly, and that works quite nicely. Obviously the command line, we don't have quite such fancy tools available to us as things like Excel and Numbers and these kind of spreadsheet applications, but we do have a command in Linux called column, and column will take tabular data like this, so delimited data like we have here. So we have comma delimited data in this case. It could take tab separated data or space separated data or any other kind of delimited data that's intended to be a table, and it will allow you to display it as a table. So in order to do this, we need a couple of options for column. So the first thing that we want to do is tell column that we want a table as an output, and to do that, to begin with, you give it the option -t. So this is telling column that the output that we want to see is a table. So please show us this output as a table. Then the next thing that column needs is to know what the delimiter character is, what the separator character is between your fields in your table. And the option for this is -s. So that's saying this is the separator in my file, and then we're going to give it the comma as the separator, and I'm going to enclose that in single quotes just to make sure that nothing funny happens at the command line, because if this was a character that meant anything to bash, to our shell, to the interpreter here, then if I didn't enclose it in single quotes, bash would try and interpret that character and it would do strange things. So we're going to give it the comma as the delimiter, and then the final thing that it needs is the argument, which is the name of the file. So example.csv is the file that we downloaded. Okay, so what this will do is we'll take the contents of our comma separated value file, and it will present it in the terminal as a table with all of the columns nice and neatly lined up. And it will do that by default for the whole table all in one go. So it's working here like cat, and it's splurging our table out to the screen. But hopefully what you can see is that each of the columns is now lined up with all of the other columns. So if you look down a column and, okay, my table is going on, each row of my table is going on to 2 lines, which is not terribly helpful. If I had a wider terminal or smaller font, it would all fit on one line. But all of my columns are all lined up with each other. And you can see this more clearly if you look at the top of the file. So to do that, I'm just going to go back up to my column command. So what column does here is it works like cat, and it prints all of its outputs as standard out. So what we want to do is we want to redirect that output. And we're not going to redirect it to a file. We're going to redirect it into another command. So if you remember from the end of last week, I briefly introduced the pipe character for doing this. So this is, instead of the greater than symbol, which would take this standard output and redirect it into a file, this pipe symbol, this little vertical line, which you can usually find by doing shift and the character next to your enter key if you're on a Mac, or shift and I think it might be the key next to your shift key on a PC keyboard. The pipe symbol then will redirect, instead of redirecting to a file, will redirect to another command, and we're going to redirect this output into less. Okay. Okay, so pipe into less, hit enter, and there you go. So that's our table, and you've got a header line at the top of the file. So now you can see that the header, so our ENSG gene header is lining up with our ensemble gene ID, and our base mean header is then lining up with this first number in the file, and so on. So all of our columns line up with all of the results in the file, and the columns are as wide as the widest number in that particular column. Yeah, some comments about various keyboard settings in the comments. I can see. I'm afraid that there were some issues with keyboards as well last week, because if you're on a Mac, your VM is not going to honour your Mac keyboard. It's going to try and set you to have a PC keyboard, and things can get very confusing. So actually, it might be wise to copy and paste the pipe from Peter's comment there. But of course, copying and pasting between host machines and VMs is not straightforward either. Usually, the pipe and the backslash are on the same key. So if you find backslash, then you'll find the pipe. But it's not that straightforward, I'm afraid. I wish it was easier. You can set the keyboard settings of so for instance, in my VM, in settings on the right hand side over here, and then in keyboard, I've set my keyboard up in layout. I've set my keyboard up to have the Mac layout. So you can do that if you want. If you've got a Mac and your keyboard is becoming particularly confusing, you can set your VM up to use your Mac keyboard layout, so that the characters that come out are actually the characters that are printed on the keys on your keyboard, which can be quite helpful. So I've set mine up for that because I'm using a Mac here, so it is possible to do that. Okay, so that's column, and we can use column in a pipe as well. So you can use when we're starting to work with this data, if we get the output as a CSV file, we can pipe that into column, and that will display those results in these nice tables, rather than displaying it in the CSV format. Okay, Q to quit less. Okay, so that's column, which allows you to get these slightly more pretty views. So the next couple of tools that we're going to do are now things to start to work with this data. So the first command that I'm going to introduce to work with data is the command cut. Okay, so cut is used to pull out particular columns from tabular data. So we're going to use cut to start slicing this data up a little bit and just giving us particular columns out of the data, which can be quite useful for other purposes. So in order to figure out how to do this, I'm going to have to read the man page because we're now, as we move away from the really common tools which you use almost every other command, like ls and cd and things like that, we move into the tools which you don't use as often, and therefore to remember exactly how it works, I have to refresh my memory of the options. So to do that, I use the man page. So I'm going to type man cut, and this tells me how cut works. Okay, so by default, cut expects tab delimited text. So it says here on, if we go down to the -d option, -d is telling cut what delimiter to use. So this is where these tools start to get a little bit confusing. So whereas column used -s to tell the delimiter, because it was -s was separator for column, for cut it's -d for delimiter. So we're going to use -d to tell it to use the column for the delimiter, instead of by default it would use the tab. And then we're going to use -f to say which fields it is that we want to retrieve from the file. So which columns do we want to get back? Okay. So they're my two options that I'm going to give it. So I'm going to press Q to quit man, and then I'm going to run cut. So cut. So it's -d for the delimiter, which, if you remember, is the comma in our data. And I want the first column and the last column. So I want to get the ensemble gene ID and the HGNC gene symbol that maps to that ensemble gene ID. So that's the first column of my file and the last column of my file. So the first column, so these are the fields that I want to retrieve, so -f. The first column is column 1. So we count from 1 for cut. There is lots of programming languages where you count from 0, not from 1. But in this case, with cut and with a lot of these other tools, we're counting from 1. So that's our ensemble gene field. And then we need to count across to get to our HGNC symbol field. So if ensemble gene ID is 1, this is 2, this one's 3, this number's 4, this number's 5, this one's 6, this last penultimate column, the last number is 7, and the HGNC gene symbol field is 8. And the F argument takes a comma separated list of fields that you want to get back. So I want field 1 and field 8 back out of my CSV file. So I put a comma between the 1 and the 8, but no space. If you put in a space, then Bash is going to do funny things because our interpreter tries to split things up on the spaces. So it's going to think that the 8 is something new and is disconnected from the 1. So we put a comma but no space. And then the final thing that cut needs is an argument which tells it which file to work with. So example.csv. And what this will do is it will print to standard out all of the first field and last field from our CSV file. So here it goes, first field and last field. So that's our ensemble gene ID is the first field, and the HGNC Human Gene Naming Consortium gene symbol is the final field. So that's given us that data back. Again, if we want to use redirects here to make this output more digestible, then we can absolutely do that. So cut is printing this to standard output, and most of the Linux command line tools that we're using do that. They produce their output to standard output, which means that we can use the pipe symbol again to redirect that standard output into another command. So we could redirect it into less and show it page by page. So here's the top page of that output, and then we press space to go down to the next page, and so on. So that's us going page by page through our file. Press Q to quit less. We could also pipe it into column in the same way as before, -T, -S, comma. But this time we don't need to tell it the file because it's taking the input from our standard output. So rather than giving it a file, we just assume that it's going to consume the standard output, which is what will happen. And this will give us that data in a nice table format. And then we can combine those two things and we can pipe the output of less. There's no limit to the number of pipes that you can use. You can take the output from one command and put it into the next command, take the output from that command and put it into the next command, and so on and so on. So we can take the output from column and put that output into less to give us the tabular output as page by page. So there you go. That's our table of ensemble gene ID and symbol. Gene symbol. We can also redirect the output. Instead of redirecting it to different programs, we can redirect it to a file. So I'm going to do this with the original CSV output. So I'm going to press Q to quit less, and then I'm going to go back up to my original cut command, and I'm going to add a pipe on the end of this and pipe it to a file. So ID symbol .csv. Okay, so this will sorry, not a pipe. Come on, Simon. Greater than, redirecting to a file. So greater than symbol to redirect to a file. So this time, instead of sending it to a different program, we're sending it to a file, and I'm calling that file id_symbol.csv. Okay, so I'm going to hit enter. We get no information back because that output, instead of going to the screen or going to another program, that output has now gone to that file. So we can list our present working directory to show us that that file has been created. So id_symbol.csv has been created, and then we can have a look at that again with less id_symbol.csv to show us that data in less. Okay, so then press Q to quit less. Okay, so that's cut and how to use cut. Just a quick note on file names actually while we're here, because now we're not just creating kind of empty files or files with trivial contents, we're working with data, and it can be handy to get your file names straight at this point. So the extension, we've been adding .csv on the end of these files. At the command line, the extension doesn't really mean anything. It doesn't direct the command line to use a particular program with that file like it would do in Windows, for instance, where a .csv file in Windows will be opened by Excel. There's nothing to say to the command line, oh, use this file as a CSV file, so use this program with it. That's not the purpose of the extensions at the command line. The purpose of file extensions is really for your information, for letting you know what kind of file this is. So it's more convenience than anything else, but it can be good to get into habits of naming files in ways according to their contents. The other thing is you'll notice that I put an underscore in that file name for the file that I just created. That underscore is mainly because the command line doesn't like to have spaces in file names, and that's because the spaces mean something to your interpreter. So if you have spaces in your file names, then things can get quite confused. So I tend to use underscores or hyphens in place of spaces in file names, because that way you kind of save your interpreter from tripping over the spaces in file names, which are different from the spaces that you use to kind of break up your command into different pieces. So it's important to kind of appreciate that the space is a meaningful character to the shell, and so you want to avoid using meaningful characters in file names. So that includes things like the greater than symbol, the pipe symbol. If you try to use these characters in file names, then things are going to get very, very broken very, very quickly. So stick to alphanumeric characters and underscores and dots in file names. Okay, so that's cut, and we can use cut to pull out particular bits of information from our file. And I don't want to do too much more today, because I realise that what has happened kind of in the gap between week 1 and week 2 is that I've managed to ramp up the difficulty quite significantly in a single lesson. And I do appreciate that, and I appreciate that you've gone from that a lot of you may have gone from not having used the command line at all a week ago to me writing commands with lots of pipes in, which look very, very confusing if you've never seen anything like it before, in just a week. And so that difficulty does tend to ramp up quite quickly when we get to this stage. So I don't want to overwhelm you with loads and loads of information today. And I will, before we finish, just quickly review those commands that we've used today. But I want to do one more command before we finish. And that final command is the sort command. Okay, so sort is, as the name suggests, a command for sorting the contents of files. So sort will, in its default mode of operation, so let's just run sort with our example.csv file as input. What sort will do by default is it will take the lines of your file and it will sort them based on the alphabetical order of the beginnings of the file names the alphanumeric order of the beginnings of the lines of your file. So it will sort the lines according to the alphabetical order of the beginnings of those lines. So if you look at this, the output, it's been sorted based on this beginning of the line. So effectively what this has done is to start with, it's moved the header of the file down to the bottom, because lowercase e sorts after uppercase E. So all of the other lines which begin with an ensemble gene ID all begin with ENSG in uppercase, whereas this starts with ENSG in lowercase, and lowercase sorts after uppercase. So the header line comes down to the beginning. So it comes down to the end of the output, and all of the other lines are sorted according to the alphanumeric order of the identifiers. So to ENSG 00002845543 sorts after 284540, okay, because 3 comes after 0, and so on. So it's sorted those in the order of that first column, effectively, which all begin ENSG and a bunch of zeros. That is one form of useful, but not necessarily the most useful thing that you will ever find. It can be more useful to sort on the order of some of the other columns. So the other columns in this file are the data that we're working with. So perhaps we want to sort, and if we look at our header line here, you can see that we've got ensemble gene ID And then we've got some statistics that are calculated from some gene expression data. So base mean is the average sort of expression level across the whole data set that I was analysing. The next column is the fold change, so that's the amount that gene has changed its expression in the comparison that I've done. We'll come back to these metrics in a much later lesson. The next column is the standard error of that fold change. This is a test statistic. The stat column, the p-value is the p-value that's calculated from that test statistic. And the p-adj column is the adjusted p-value. So that's a p-value that's been adjusted from multiple tests. And then finally, we have the gene symbol. So that's the symbol column is the gene symbol, which I've added on to the end. So maybe we want to sort, instead of sorting on the basis of just the gene name, maybe we want to sort on the basis of the fold change, so the magnitude of the change of expression. So we want to sort on that column of the data, and sort allows us to do this. So again, we'll just quickly look at the man page for sort to check out how we do that. So we want to be able to sort on one of the columns in the data. So in order to do that, we need to look down these entries in the man page for something which is going to allow us to do that. And so the things that we need to determine are a bit further down. So this is not very obvious, but -k is the key. That's the thing that says this is the column number that I want to sort on. So k takes the number of the column that you want to sort on. And then this time the field separator is obviously something different again, because God knows we don't like to standardize. So -t is our field separator in this case. So it was -s in column, it was -d in cut, and here it's -t, because, you know, if they were all the same, that would be easy. We don't want to make things easy, do we, apparently? Unix people from the 70s. Right, okay. Sort. So our delimiter in this case is -t, and it's still a comma. Okay, so that's our delimiter, and we want to sort on the log fold change column. So that's column 3. So 1 ends gene is 1, base mean is 2, log 2 fold change is 3. So we want to sort on the third column. So we need a -k3 to sort on the third column of our data, and then our input is example.csv. Okay, so that's our input data, and this time I'm going to send the output of this to less, so I can see it from I can see it a page at a time. Okay, less. So pipe into less to show me the output one at a time. There we go. So this is showing me the output, and now it's ordered by that fold change column, so the third column in the data. Now this perhaps isn't ordered in quite the way you might expect. So log 2 fold change. So, okay, if you know about the data, and it helps to know about the data here, but log 2 fold change could be ordered from -infinity to +infinity. But because this sorting is happening in alphabetical order, not in numerical order, the thing with the most zeros sorts to the top. So 0.001 sorts to the top. And then as you go further down, you'll find it looks superficially like it's in numerical order, like it's getting bigger as we go down. But actually what you'll find is that further down, there will be minus ones and minus twos that are smaller than these minus 0.00s. And it's not sorted those in the right place. And the reason for that is it's sorting on alphabetical order, not on numerical order. So we have to add another option to get sort to order in numerical order rather than in alphabetical order. So we're going to go back to the man page for sort to find out what that is. And we're looking for numerical sorting. So you've got two types actually. You have you have dash n, which is your numerical sort, which is a string numerical value, and then you have dash g, which is a general numerical sort, which compares according to general numerical value. The dash g, the general numerical sort, will interpret e's properly, so things where you have rather than one e something as a string. So I tend to use general numerical sort in all cases where I want a numerical sort rather than using dash n. So I'm going to add dash g as an option to my sort command. So I'll go use up to go back in history to my command, and then I'm just going to add in dash g there to get a numerical sort rather than an alphabetical sort. So now the smallest fold change sorts to the top. So minus 6.9 rather than minus 0.001 sorts to the top of my file. And if we look down at the bottom, so if we just let the whole thing print out to the terminal, you'll find that at the bottom there is the largest p-value, so plus 6.9 sorts to the bottom of the file. So that general numerical sort is working to put this data into the order that I want it, which is quite useful. So that's good for sorting our data according to some criteria. So in this case, we're sorting according to the fold change. You might equally want to sort according to the p-value, for example, because the p-value, obviously the smaller the p-value, the more significant your result. So you might want to sort so that your significant p-values, your smallest p-values are at the top of the file and your least significant p-values are at the bottom. The other thing to note about this is the header line. And tables quite often have header lines that say, okay, this is what all the columns mean in my data. And when you sort your data, there's nothing which tells the header line to stay at the top of your data. There's nothing restricting it from being sorted like everything else. And in fact, in the case of this particular data, you can see if you look at the bottom, the header line isn't at the bottom. And if you look at the top, the header line has actually stayed at the top. And that's because in a numerical sort, anything which is alphabetical will end up at the top. So actually our header line has stayed where it's meant to stay in this case. But that's not necessarily always going to be true. It may be that it sorts to the top. It might sort to the bottom like it did in the sort that we saw before. It might sort to the middle and get lost completely amongst your data. So it can be very helpful if you're doing a sort to remove that header line, at least temporarily, for your sort. And there are ways of doing this. So what I'm going to do for the end of the lesson is I'm going to do something quite complicated and leave you to kind of mull on it overnight. Okay, so what I'm going to do, the first thing I'm going to do is I'm going to take that headline and I'm going to write it out to a new file so that we have a record of the header. So in order to do that, I'm going to use head, and I just want the first line. So I want to use the -n argument for, sorry, the -n option for head and give it the value 1 to say I just want one line from the head of my file. Okay, and I want from example.csv. Okay, so this is going to give me the first line of example.csv, and I can run it without redirecting it to show you that that works. Okay, so that's just the first line of the file, and I'm going to redirect that into a file. So I'm going to redirect that into a file which I'm going to call sorted.csv. Okay, so that's my first step here, which is to keep a record of that header, and it's going to be the first line of this file. Okay, so then the next thing that I want to do is I want to sort the data, not the header, but the data. So in order to do that, I need a way of just extracting the data from the file and leaving the header behind. And to do that, I'm going to use tail, and I'm going to use a feature of tail, which is really convenient. So to do this, I'm going to show you the man page for tail, first of all. So the -n option for tail here, so -n works exactly the same way as -n in head. So in head, you do -n1 and it shows you the first line of the file. If you do tail -n1, it will show you the last line of the file. But tail also allows you to give an optional plus to this argument. So, and if you read the documentation, it says output the last num lines instead of the last 10, which is the default behavior, or use -n plus num to output starting with line num. So you can use tail to say, give me all of this file from line n to the end, okay? Which is different to saying, give me the last 10 lines. And say, give me everything from line 200 to the end of the file, you would do tail -n plus 200, and that would give you everything from line 200 to the file, to the end of the file. So what we want to do is exclude the header. So we're going to use tail to do that and do -n plus 2, okay? So that will give me all of my file from line 2 all the way to the end, okay? So -n plus 2 example.csv. So that gives me just the data, not the header, not the first line, but from the second line all the way to the end of the file. Okay, then I'm going to pipe this into sort, and I'm going to use sort in the same way as I did before, but instead of sorting on the log2 fold change, I'm going to sort on the adjusted p-value, which is the penultimate column. So that's the 7th column rather than the 3rd. So I'm going to do -g, because it's still a number, so I want a numerical sort. I want -t, so this is my separator, so that's a comma. And then I want the column, which is -k, and rather than 3, which is what I did before, you can see it a few lines above on my command line. Instead of -k3, I want -k7. And I don't need to give it a file this time because it's taking its input from standard output. That's what the pipe character is doing here. It's sending the output from tail into the sort command. So this will sort my data, and not my header, on the basis of that 7th column. Okay? So just to check that this is working, I'm just going to send that to standard output. And what you can see then is the last 4 lines, they all have a p-value of 1. The one above that has 0.9999996, and so on. And if we scrolled up through this, you would find those p-values that in that penultimate column getting smaller and smaller and smaller as you go back up the file. So we can pipe that into less to see the most significant genes at the top. So here's the top of the file. And you can see this gene RASSF3 has a p-value of 3.57 times 10 to the minus 299, which is an inconceivably small number. So this is a statistically extremely significant result. It's a slightly worryingly small p-value, actually. You can see that our sort has worked, that our smallest p-value has sorted to the top of the file, and our largest p-value has sorted to the bottom. So the last thing that I want to do, very last thing in today's lesson, is rather than piping the results of that to less, I'm going to redirect it to a file, and I'm going to redirect it to our sorted file, but I want to leave the header there, so I want to append to that file. So greater than appends rather than creating a new file, and this will add the data to that sorted.csv file that I created by piping the header in. So now we've got our sorted data, and we can use less to look at that sorted data and see that we've still got our header because we put that in using head -n1, and we've got our data now sorted from the smallest p-value at the top of the file to, if we use tail, the largest p-value at the bottom of the file. So the p-values of 1 right down there at the bottom. So we've used these command line tools to manipulate this data in various ways. So just to recap, and I know I've gone on slightly long today, so I want to quickly finish up with a quick recap and hope that my whiteboard is working. Just to remind you of the commands that we have used today. So let's go to my whiteboard and see if we're synced up. And if not, I'm going to... Yep, there we go. So what have we used? We used wget for downloading our data. Once we had that data, we used a few tools for looking at the contents. So we used wc for counting the bytes and the lines in that file. So wc -l for counting the lines. We used column for displaying the data in a pretty way. We used cut for pulling out particular columns from that data. And then we used sort for manipulating the data and sorting on the data inside our file. And those are the kind of beginnings of the tools that we've used today for beginning to work with data at the command line rather than just kind of moving files around and doing the kind of busy work of that kind of thing. So I'll just leave that summary up and say goodbye to everybody. I hope that that's been interesting. I know that the difficulty has ramped up today, but that, I'm afraid, is inevitable at some point, and I am still trying to take it slow to make sure that the lesson is digestible and that I'm not introducing 24 commands and completely bamboozling you every day. So hopefully I've still gone slowly enough that you've understood the things that I've done today. And if you want to take a step back and to spend more time on things like redirection, then I absolutely understand that, and I can do that tomorrow. Just let me know if today has bamboozled you and you've got completely lost. Then let me know, and I'll try and do a little bit of a recap tomorrow to make sure that everybody's on the same page. Otherwise, we will continue with some other tools for working with data tomorrow. So I hope to see you tomorrow, same time, same channel, 4 p.m. Tomorrow afternoon, and we'll pick up from where we left off. Okay, so thanks everybody, and goodbye, and see you again soon. Ta-ra.